Hey guys, welcome. Today we're gonna be covering differentiation rules, and I hope you're excited because it's gonna be a lot of fun. And this can basically be applied to any calculus course, in the IB, in A levels, etc. So let's get straight into it. So, first of all, what even is differentiation used for? Well, it is used to measure the instantaneous rate of change of one variable with respect to another. Okay? So this has many practical applications, like we can find velocity, we can find acceleration, etc. Because what is velocity, guys? Velocity is the rate of change of displacement, right? It's a change in displacement over time. We can do that. We can find velocity by differentiating displacement. And similarly for acceleration, we can differentiate velocity to find acceleration. So it has quite a few useful practical applications in other fields other than maths. Nonetheless, today we're going to be covering the basic concepts of differentiating different types of questions. They have different type of requirements of what we need to use to solve them. So this is applicable for IB maths, all types. So let's get straight into it. First of all, we know that we can write a differentiating, like we can write dy over dx, we can write f prime of x, we can write y prime. It all depends on the type of question that is given to you. If you have something given as like y equals to x squared, then when you are writing the answer to the differentiative thing, you would write y prime or dy over dx. Similarly, if you're given f of x, you can write f prime of x. That's the basic notation that you need to know. Okay, let's get straight into it. So first of all, we're going to be covering derivation from the first principle. So let's write that down. dy over dx from first principles. Perfect. Okay, so this has a really basic formula, and I think it's given in the formula booklet for AAHL. I'm not sure about the other ones, but yeah, so I'll just write it down here. If you're given like y is equal to f of x, okay, let's say this is your question, and you want to differentiate this using the first principles rule. What you're gonna do is you're gonna write dy over dx is equal to f of x plus h minus f of x divided by h with a limit of h to 0. Okay, that's the basic gist of it. And essentially this part here, f x plus h, just refers to replacing x here with x plus h. Okay, that's the basic idea. So I think we should, apply this to a question so we get a better understanding. Okay, let's take this example. It says f of x is equal to x squared minus 3x plus 7. Okay, and we need to apply this first principles rule to find dy over dx or f prime of x. So what we're gonna do is we're gonna first copy down this formula here, and we need to do this every single time we use this principle to solve a question, because we want to show the examiners that we are aware of what we're doing, we have our understanding, and it's also easier for them to follow through with their working out. So it's like good practice, a good habit to write down all the formulae that you're using in your working out. Okay, anyways, so f prime of x is equal to limit of h to 0 f of x plus h minus f of x over h. Perfect. Now, as I mentioned before, f of x plus h just refers to replacing the x here with x plus h. So let's quickly just discuss this on this side. If f of x is equal to x squared minus 3x plus 7, then f of x plus h is just equal to x plus h squared minus 3 of x plus h plus 7. And we can definitely expand this, using our FOIL method. So we're going to get x squared plus 2x h plus h squared minus 3x minus 3h plus 7. Perfect. Now, we can just substitute this whole expression back into our formula, right? So we need to keep writing the limit up to like one of the end steps. So I'll show you till when. Okay, so we can write this all again. X squared plus 2xh plus h squared minus 3x minus 3h plus 7. Now it's saying minus f of x. We know f of x is x squared minus 3x plus 7. So we just need to put a minus sign at the front of each variable. We're going to get minus x squared plus 3x and minus 7. And we can divide all of this by h. Perfect. So limit of h to 0. And then now we can simplify our numerator, right? So I can see that I have x squared here and minus x squared here. That's going to be 0, so I can cancel it out. Next, I can cancel out minus 3x and plus 3x, right? And 7 and minus 7. So at the end of it, I'm going to be left with h squared plus 2xh minus 3h over h. And I can I can see a common factor in the numerator, and that is just h. So I can take h out as a factor, and I will be left with h plus 2x minus 3 divided by h. And now I can cancel these two out, and I'll be left with limit of h to 0 and h plus 2x minus 3, just this bracket. Now, as per the concept of limits, we know that we can take the value of the limit given, like the approaching value, as the variable, because it's just easier and more simpler to deal with it in algebraic calculations, right? So we can essentially just replace h here with 0. So we're going to get 0 plus 2x minus 3, which is just 2x minus 3. And that is my final answer. Fun, guys. We just solved one amazing question. And I hope you're getting the gist of the formula. So I think we should try another question together. Let's try this one. Example 2. Actually, I'll leave a line here. Okay. Example 2 is f of x is equal to x minus 2 over x plus 2. Okay. X minus 2 over x plus 2. Perfect. So this is a bit trickier because we have, a fraction, and we have variables in both the numerator and the denominator, but don't worry, we can definitely solve this. So we have f prime of x, which is equal to the formula, limit of h to 0, and then we have f of x plus h minus f of x over h, right? Now we can just copy this limit, and we can go straight into the x plus h part. So as we discussed in the last question, when we have f of x plus h, we essentially just replace the x with x plus h. So on the top part, so the numerator of the fraction is going to be x plus h minus 2 over x plus h plus 2 minus x minus 2 over x plus 2, because that's just our function, all divided by h. Okay, perfect. Now we're kind of in a messy spot. This is a really, really easy place to make mistakes in. So we need to be careful when we come to this part, because we know that when we are simplifying fractions, we need to find the LCM and all that stuff. So we can see that this is my denominator 1, this is denominator 2, so I'm gonna have to multiply this here and this here, right? So let's do that. We have x plus h minus 2 and then times x plus 2, and then we have minus x minus 2, which is the second numerator, times the first denominator. It's just cross multiplication, right? It's like that and like that. So x minus 2 times x plus h plus 2, all divided by x plus h plus 2, x plus 2, and by h, sorry, which is equal to the limit of h to 0. And then, we can definitely like expand this, I think. Yeah, okay. So we're gonna get x squared plus 2x plus hx plus 2h minus 2x minus 4. And then here we're gonna get x squared plus xh plus 2x minus 2x, oh wow, minus 2h minus 4. Right. And yeah. And then also, since we have the h here as a second denominator, this is the same as multiplying this fraction by 1 over, this fraction by 1 over h. So the h can just be moved up here. So we're just going to do that. We're going to write h, x plus h plus 2, x plus 2. Okay? So yeah. And then we can, get to cracking it. We can get to simplifying this. So we are going to simplify the bracket first. We need to take it step by step to make sure that we don't make any silly mistakes. That is like the number 1 mark killer in the IB. So we can simplify this. So x squared is just going to stay as it is. And then I can see 2x and 2x here. I can cancel this out. And I'm going to be left with plus xh minus 2h minus 4. Right? That can all be divided by h, x plus h plus 2, x plus 2. Perfect. Okay, next. So limit. And then now I can see that this and this can be cancelled. I'm so sorry. These two can be cancelled out. And then 2h, oh no, not that one, sorry. This one and this one can be cancelled out. And minus 4 and plus 4, because the minus here goes to there, so it's plus 4. These two can cancel out. Yeah, I think that's it. So let's just see. We have hx plus, oh sorry, these two can also be cancelled out. Hx and minus xh, same thing, right? The order doesn't matter because they're the same variables. These two can be cancelled out as well. So we're left with 4h, because it's 2h here and minus plus 2h here. So 4h over h times x plus h plus 2, x plus 2 times x plus 2. Okay, perfect. Now we can, cancel out this h and this h here, because, denominator, numerator, same thing, cancelled. So we're left with 4 over x plus h plus 2, x plus 2. And now we can substitute h as 0, which will give us 4 over x plus 2, x plus 2, and that's basically our answer. So we can, make this a bit neater and just write x plus 2 whole squared. And that's our answer. So I don't know if you guys have spotted this pattern, but basically we don't want h in the just h in the denominator, even if it has a coefficient. We don't want that. We don't want just h in the denominator and just h in the numerator. because if we're left with that, when we substitute it as 0, it can create a lot of issues. We don't want 0 as an answer. We don't want infinity as an answer. So we need to get rid of the h's as much as possible. That's basically what we're trying to do here. Okay, I have one more question on this one, on first principles. So let's try the third one. And I'm going to give you guys a chance first. Just try it out by yourself. I'll write it down. So f of x is equal to 1 plus x squared all square root. And it's a bit different, I know, but why don't you guys give it a shot? I hope you got a chance to solve it. Let's try it. Okay, sorry about that. So, first of all, as always, we need to write down the formula again. So f prime of x is equal to limit of h to 0, and then f of x plus h minus f of x all over h, right? Now, as we've been doing for the other questions, we need to replace x here with x plus h, right? So let's do that. So we can just copy down the limit again, and we can write 1 plus x plus h squared minus 1 plus x squared, which is just a normal function, given function. And then we can divide all of this by h. Now, what we're going to do is we're actually going to do something a tad bit different. So I'm not sure if you guys have heard of rationalizing a denominator, but this is quite similar, except you're rationalizing the numerator, which is exactly how it sounds. You're basically applying the same principle, but to the top part of the fraction. So I will show you guys how it works. We can just copy down this part as of now. So 1 plus x plus h squared all square root minus 1 plus x squared divided by h. Now, what we're going to do is we're going to copy down this whole expression. So we're going to write the same expression divided by the same expression. But there's one little twist, okay? And that's we have to switch the sign. So right now we have a negative here. That's going to become a positive. Okay, so let's just see how that's going to look like. We're going to get 1 plus x plus h squared all square roots plus 1 plus x squared all square roots divided by the same exact thing as shown here. Yep. So in this part, the denominator is going to multiply with h, and this part is going to multiply with this numerator. Perfect. So let's just, get to simplifying this, expanding this first, and we can simplify it. So this has a very similar property of what we've covered in our previous years of, math. We know that when we get a plus b and a minus b, the expansion is a squared minus 2ab plus 2ab minus b squared, which is just essentially a squared minus b squared, because these two cancel out, right? This is applying the same property here. This is our a. This value and this value is our a, and this value and that value is our b. That's the same thing. Same idea that we're using. Okay, perfect. So we can do 1 all square root 1 plus x plus h squared all squared minus 1 plus x squared, square roots. Oh, this is kind of getting messy. Wait. Minus 1 plus x squared all squared divided by h, and then this whole expression. So 1 plus x plus h all squared, all square roots, and then plus 1 plus x squared all square root. Okay, so we know that when we like square a radical, the square root just cancels out, and then we're just left with the expression inside of the radical, right? So basically the same logic is applied here. So we're just gonna get 1 plus x plus h squared minus 1 plus x squared, and then the denominator is gonna be the exact same. So that's a bit lengthy, but yeah. So let's just copy that. Perfect. Now we're gonna do limits. Again, just copy this down. We can quickly expand the numerator. So we're gonna get x squared plus 2xh plus h squared plus this 1 at the start minus 1 minus x squared, because we're distributing this minus sign to these two variables, right? So we're gonna get that, and then we can write the denominator. Sorry for my voice, it's like I have a really bad sore throat, so just trying to make it through. Anyways, so we have limit of h to 0, and then now we can simplify the numerator by, collecting the like terms, canceling out, whatnot, all that magic. So we can cancel out these x squareds because that's positive, that's negative, cancels out, and then this plus 1 minus 1 cancels out. So we're just left with h squared plus 2xh over h, and then this lengthy denominator. Oops. Okay, now we can see, as we saw in the first question that we did, that we have a factor of h in the numerator, so we can just take that out as a factor, and we're going to be left with h plus 2x, and then divided by this denominator, 1 plus x plus h squared plus 1 plus x squared. Okay, now we can cancel these two h's out, which is gonna leave us with limit of h to 0, h plus 2x over 1 plus x plus h square root plus 1 plus x squared. And now we can do that same thing, like take h as 0, so we can sub h is equal to 0, and then that's gonna give us 0 at the top, so we're just gonna be left with 2x, and then we can also sub in h as 0 here in the square root, so we're gonna be left with 1 plus x squared plus 1 plus x squared, and we can collect like radical terms, like the same radical terms together, right? Because it's the same exact values inside the radical, so it's essentially the same thing written twice. So instead of doing that, we can make it a bit more tidier and write it as 2 1 plus x squared, and then we can cancel out the 2's as well, make it extremely neat, extremely simplified. So these two cancel out, and we're gonna be left with x over 1 plus x squared. That's our final answer. And boom, guys, we did it. So I'm aware that this video is getting a little bit longer than what it's supposed to be, so I will cover the power rule in the next video. So stay tuned for that, coming soon, and thank you for joining. See you. Bye.